All right, cool. So we are almost to like diving right in, but we just wanted to kind of go over how this is all going to look. So, like Vanessa said, this is the first of a three-part series where, everybody here, we're going to be building a PC together. So, this one we will go over the components and what they do and kind of like how they work. And then in the next one, which will be 2 weeks from today, we will actually choose the parts for the PC that we will build in our third meeting. So like I said, this one is just going to be the components that make up a PC. And so we have this giant list of components that we are going to try to go through with you all here, kind of on like a high level, but we're going to go from everything from the central processing unit to ending with like input devices and display devices and stuff like that. So hopefully by the end of this, you'll have a bit of an idea of what each of these parts does inside of a PC.
Like Janelle said, we're going to be discussing various components. The first one that I wanted to talk about was the central processing unit, also known as the CPU. Every computer contains at least one processor. And what it is an electric circuitry that retrieves and executes instructions. These instructions can come from programs from the operating system and many other different components within your computer. However, this is like it's able to retrieve these instructions because the CPU houses millions of microscopic transistors. What they do is that they represent binary code. And if we recall, binary code is ones and zeros. And they're able to represent it using electrical signals, which is on or off. And because the CPU houses millions of these microscopic transistors, it's able to execute more complex tasks at very high speeds. And as technology has advanced, CPUs have also become more efficient and been able to accomplish more complex tasks at very high speeds. The CPU sits in the socket of the PC's motherboard that we will talk about a little bit more later on. And once it's set on the socket of the motherboard, then other parts of the computer can connect to it. The next component that I wanted to talk about is the motherboard. What the motherboard is a circuit board that allocates power, and it also allows communication within other hardware components of the computer. And it is a single platform that connects all these hardware parts via ports that it has. There's multiple motherboards designed to fit different computers of different sizes. Generally, on the left side of the motherboard are located many ports that connect the monitor, it connects the mouse, it connects the keyboard, the speakers, as well as USB ports for devices that connect by plugging in or plugging out. Where it got its name from is because there are smaller circuit boards that connect to the motherboard, like hence the smaller circuits can be referred to as the children circuits because they're smaller and they connect to the larger center circuit board that is the motherboard. Where the motherboard is located is the computer case that we will also talk about as another component. The next component that I want to talk about is the memory. Memory can be either volatile or non-volatile. Volatile memory is memory that is lost once the computer is shut down. RAM, in this case, would be volatile memory. RAM is also known as short-term memory. An example of short-term memory would be, for example, editing a document that is stored in the RAM, and it would be lost if it was not saved to a non-volatile memory, for example, a hard drive. Another example of RAM is internet browsing, because it loads from your hard device and it's placed in the RAM. And anything you save, such as an image or video, gets saved on the hard drive for storage. So that leaves the RAM and it's stored in a hard drive. So you will typically always have more hard drive memory than RAM, which is a good thing. This will be connected to the memory slot on the motherboard. The next component that I want to talk about is storage, which is non-volatile memory that is stored when your computer is shut off. Storage components are used by your computer to allocate storage in bulk data until it is necessary to use, and it will store it for an indefinite period. Some examples that get stored in your storage are applications, the operating system, and files. There is 3 categories for storage. One is internal storage, which is a storage device that exists inside your computer, like a hard disk drive. Another category is external storage, housed outside the computer, for example, a USB hard drive. And then the third category is network storages, dedicated to store devices in your network, which provide shared access to data to multiple computers over a network and to different people.
I'm gonna go ahead and pick up here at the graphics card. So the graphics card controls and outputs visuals, but we will learn that might not be all true because some PCs don't have a graphics card, but we'll go through that. So a graphics card, like I said, controls and outputs visuals, but this is specifically for graphics heavy tasks. If you are playing games that are like go at really fast speeds or like have lots of detail to them, like in this video, it shows Cyberpunk with different graphics cards. So you can see this is like an older generation graphics card. And this is like a newer generation, but like what I want you to notice is how many like 3D objects there are here that the computer has to render, and how kind of high end this is with like all of the lighting and stuff like that. So this is kind of something that you would want a graphics card for. Why do we need a graphics card? So just to kind of put this into perspective, the whole like role of a graphics card is it's going to take binary from the CPU and it's going to convert that to whatever the image is on your screen, right? So if you think about your screen, it has so many pixels and each instruction from the CPU in binary has to be converted to a pixel value. And so that is very demanding when you think about how you have to create like the wireframes for all of these objects and you have to fill the object in. And then you, on top of that, you have to add any color, texture, or lighting, or anything like that that's going to make the object seem kind of real on your screen. Now, you might not need like a GPU for everyday use, but it's still the same thing that's happening is where binary from the CPU is what's creating the pixel value for each of the pixels on your screen. And beyond this, especially for like gaming and things like that, it needs to do this quickly. So if you think about an HD screen, and we'll say that's just like a little under 1 million pixels. And if you're trying to get the frame rate of 40 frames per second, which means that your computer is putting up like different images 40 times in a second in order to produce a video stream, then that means that you're gonna have to fill almost 40 million pixels per second. And that's a lot. So that kind of motivates the need for a separate processor just for graphics. And that is on the graphics card. And the processor is called the GPU, or the graphics processing unit. And this will calculate the values to render images. So you can see kind of the difference on like the CPU, like it has some like arithmetic logic units and stuff like that. And the GPU is a little bit different. It's set up with more cores. So like each of these lines can run its own process. So that way it's built for parallel execution. So you can say, that's just a fancy way of saying like, oh, I could calculate the pixel value for something like over in this corner at the same time that I'm calculating the pixel value for something like over in this other corner. So that's really why the GPU and the graphics card really helps out, because it can just compute and provide so much more power and so many more cores to handle solely the pixel values that are coming through on your screen. And the graphics card also contains RAM. It stores completed images, and it stores the ones that have been previously shown on the screen. That way, you know, if you're playing a game and like you're driving a car and you like go to back up, you know, it doesn't want to have to render all of those images again. It can kind of pull from short-term memory, and which is called VRAM for graphics, or like video RAM. And then the same thing goes for images that it's waiting to put out, right? Because you don't want to be just keeping up with how many images you're supposed to have on the screen. Like, you want to be a little bit ahead, you know, have some in like the queue waiting. That way you can have a steady video stream. And so from the graphics card and from all these computations, then next the signal is going to go to the monitor. Just something here, it's not necessarily really important to note, but the CPU gives binary, which is discrete values, so like zeros or ones. And so that's like a digital signal, because we either have like this value up here, which would be like a 1, or this value down here, which is like a 0. But when it's going and sending the final signals to the colors channels on your screen, it's going to convert it to analog, just to get a little bit more of like that continuity, and then that way it's not like as grainy. And then something that I forgot to mention was, you see like this is highlighted on here, and this is just showing the video RAM on the graphics card. This would be like the GPU. This right here would be like where you connect it to the motherboard. And these are the memory spots for video RAM. So I mentioned before that not all PCs or computers need a graphics card, really. So your computer in everyday life, you know, if you're just going to school, logging onto Blackboard, you probably don't really want high-end graphics. And so that is something in the case where maybe you have integrated graphics, which is a little bit slower because it doesn't have like, you know, all the extra benefit of an entire graphics card for all of those cores to calculate all of those things. And it'll share the same memory bank, the same RAM as the central processing unit, but you can get by, and it will actually use less power because you don't have this whole other card running all of these other functions on all of these other binary instructions from the CPU. So it will actually use less power, and then you won't be as worried about like your PC overheating or something. But with that being said, if you want to go like really high-end gaming, maybe a graphics card is for you, because this again is that same game, Cyberpunk, and it's very demanding. And we see up here we're at like 8 or 9 like frames per second, which lags out pretty bad, just because it doesn't have all those extra cores to calculate all those pixel values really fast. So it leads to some lag, and like, oh, you might like crash or something a little bit more. But also you can still play games without having a GPU. So this is Fortnite, and you can see that this is like up around like 60 frames per second still. So it really depends on how demanding your game is as far as graphics and kind of like the quality and like the picture that you want to see. But yeah, I didn't mean to scare anybody saying that you absolutely need to buy a graphics card or else you're just not going to have a good time, because that is not true. So next we'll be talking about the power supply unit. And so the power supply unit, we have in this little caption here, it says it gives this PC its power. But that's something that I want to kind of debunk a little bit, because the power supply unit is not the source of like power for your PC. What the power supply unit does is it will convert the current coming from the wall outlet into a current that is within your PC's tolerances. So you see like AC and DC. AC stands for alternating current because the current changes like directions periodically, and then DC just stands for direct current. It's just current coming into your machine, and it's interesting because different like wall outlets and stuff have different levels of currents. So for example, in the UK, like the voltage coming out of your wall outlet will be 240 volts versus like the US, it's different. It'll take whatever that voltage and whatever that current is, and it'll take it into the system, and it will make it so that the voltage is within the range that it needs to be for your PC and all of its parts, because each of its parts is going to require a different amount of volts. And so, for example, if you have like a really new graphics card, that's going to get 12 volts, or some of your like fans or USB ports get like 5 volts of power, and then like 3.3 volts to the CPU. It's just nice to know that different components in the PC receive different amounts of volts, and the power supply unit is something that helps regulate this, which is important because you don't want to fry your parts by sending 50 volts to something that requires 12 volts. So a little bit more about the power supply unit is that whenever you're like looking for a power supply unit, something that I thought was worth mentioning is that if your system is going to require 600 volts of power or something like that, that's just like a random number I threw up there, you'll need a 1200 volt power supply, because you want your power to be supplied at 50% load. So you don't want to be needing like all of the power that your system can like handle and everything to be coming in. So you don't want 600 volt power supply and just kind of be running it at the max and like pushing that. And the same thing goes for efficiency. So as far as your power supply unit, the standard efficiency is 80 plus, which means that you want 80% efficiency at minimum with a maximum load. So if you are using like all the power you can, you want to be 80% efficient with that power. And like what efficient means is you would take the DC power output to all the components, so the power that your PC is actually using, and then divide it by the watts that you get from the source, or like your wall plugin or something like that. And so now we're going to talk about cooling, because regulating the temperature inside your PC is really important. Your components in a PC will require cooling, because if components like overheat and get too hot, like with all of those calculations going on, then you can actually end up damaging your components and like frying all of your parts, and then they won't work anymore, and that will not be any fun. There are different ways that you can like regulate temperature inside of the case that is housing all of your PC parts. One of them is fans. So you'll see in some images later when we show you images of like all these parts together that some specific parts do have like their own fans. So like on top of like the CPU or the GPU, since those are very like compute heavy, like they need to be giving instructions or calculating a lot, you'll see some fans on top of those. You can also see like fans on the cases, or case fans that will actually pull like cool air from the front of your PC, and then they will circulate the air through the PC, and then the hot air will go out the back of the PC in order to keep it kind of cool. There are also other pretty neat ways to cool. One of them is liquid cooling. Liquid cooling works by transferring whatever heat your processors make into water. So you'll see here this like little square, and this is called the water block. So it'll sit on top of like a CPU, then I'll take the heat from that processing unit, and it goes like into the water, and then the water will go through these tubes back to this part, which is called the radiator, where these fans on this part will cool the water down and then recirculate it back to the water block. So it tries to keep like a CPU cool that way. And then also probably the more like general thing that a lot of people have seen that's kind of common is like heat sinks. And this is this nice like gray thing here. And it just gives the heat an area to like dissipate over, because there's a lot of surface area on heat sinks. And so they're usually made out of like aluminum because it's cheap and it conducts heat, and you can therefore make a lot of surface area that conducts heat. But if you're looking for something that maybe needs a little bit more like thermal conductivity, like you're really like maxing out your PC or something like that, then copper is also an option for that. And then now we're going to talk about cases. So a case is what encases your build. It's a way to physically mount all of your components and just have them all like in one area. But beyond that, it's a form of physical protection for your PC. I would not recommend building a PC and then like leaving it out like this, but to each their own, because there's just so many things that can go wrong if you have different like substances or dust or anything like really build up on your components. It could cause problems, or if like you're walking by and like you spill something on it. So just having a case really kind of gives that physical protection as well. Case is also kind of a method for cooling. We talked about fans and case fans, and so you can see here's some like places where you would like put a fan, and it could take it from like the front of the case to the back of the case. And beyond that, cases just look really cool. It's actually like a table, which I thought was pretty cool, but people do all sorts of crazy things with them. They make cases like out of their displays and stuff like that. There's a lot more that you can do than just this like black box that you'll see probably at like most high schools or universities or anything like that. So cases can be pretty cool. And I think for this next slide, I will turn it over to Vanessa to talk about display devices, operating system, and input devices.
First, I'll talk about the operating system. The operating system is a software that allows you to interact with the computer, and the operating system is stored in the storage. It has 5 basic functions. The first one is interface between the user and hardware. And what this means is that, for example, this interface can be graphical user interface, in which the users click on an on-screen element, such as a button, to interact. Or also with the command line interface, in which the user types a command. The next function is that it allows communication between the hardware components. For example, the operating system has a specific translation software called device drivers that allows hardware components to kind of talk to each other. The third function is that it provides environment for softwares to function. For example, the software of an application is very specific and it has certain tasks that it must execute, and the operating system allows for applications to run in a consistent graphical desktop environment. The fourth function is that it provides structure for data management. And what this means is that with the operating system, you're able to view files and directories and manipulate those files by whether it be moving or renaming or deleting. The fifth function is that the operating system allows you to monitor the system health and functionality, which means that you can check on how busy the computer processor unit is and how quickly it's able to access data and retrieve that data. In this image that I included here, I kind of wanted to show the interaction with the operating system has with applications, with monitors, with printers, with all these devices, to show kind of how in some cases that interaction can be bidirectional, such as in the case with applications and hard drives. And you kind of see here how they're able to interact with each other. The next component that I wanted to talk about was display devices. It is a pretty simple concept. Output devices, such as the monitor, for example, allow presentation to be visually represented. And then we have input devices that is hardware that sends data to a computer. This includes keyboard. It's used to input data and commands. Another input device is a mouse, in the way that used to control the cursor and coordinates, and it sends data to the computer. Another example of an input device is a webcam. It's able to capture still images or videos, and it's able to send that data to a computer. And then in contrast, we have output devices that receive data from the computer, and it can translate that data into another form. For example, monitors, in the way that it takes data and it presents it in a visual form. And then we also have headphones, in the way that it receives data from a computer and it outputs a sound. And then another example would be computer speakers, in the way that it receives vibrational cues from the computer and it's able to convert it into audio. And I included this Venn diagram here on the right side to visualize the different components and where they lie, and to see how some components do share. They can be both input and output. Then I'll pass it back to Janelle on this one.
Yeah, so we've kind of like gone through together very briefly, you know, all of the components in a PC, and like in our build and everything, we'll be building these like main components like up till the case. And so I just wanted to give like a couple pictures and visual references for where everything's at, because we've been talking about all these parts, but like how does it fit all together? So we can see here, like there's this little square, there's a giant fan on top of it. Like I said, CPU will need some like additional cooling. But under the fan will be a CPU, which is, like Vanessa said, is in the socket on a motherboard. And the motherboard is usually kind of propped up like against like the back of whatever case. Again, some of those like crazier, cooler cases might align stuff differently. But also on the motherboard, there's going to be slots for like RAM. In this one, it's kind of hard to see. These up here might be RAM, but it just looks like horizontal like slots that you can literally click sticks of RAM into. And then we have like the GPU, which is like the graphics processing unit, and so this is on the graphics card, which usually has fans on it as well. But again, same thing, very similar to RAM in how it can just kind of like click into the motherboard. And then usually down towards the bottom of your case, you will have your power supply unit. You can have some like storage. So Vanessa's talked about like storage, which includes like solid state drives. That will usually be somewhere kind of off in the corner. And then we have cooling, which is your case fans. Sometimes you might have like fans on the front, like a front panel or vent or fan, and cooling can look a lot different, like we've seen with liquid cooling as well. And this is what we can expect to build by the end of this, which is pretty exciting, just kind of doing it all together.